Hello everyone, this is Manish from Skillable India, and in today's session of geometric dimensioning and tolerancing, we are going to start the fourth geometric control in the form control geometric tolerance, which is about the cylindricity. Okay, so this is the last and the fourth geometric tolerance under the form control. Okay, so first we will understand the uh, definition. So the cylindricity symbol. So this is the cylindricity symbol. Whenever we are using like this, so this some symbol under the box is called the cylindricity symbol. Okay, so this symbol we use for the cylindricity. Cylindricity symbol is used to describe how close an object conforms to be to a true cylinder. Okay, so whenever there is a circular round profile of a length, okay, let's say we are talking about a shaft. Okay, so in this example, if we are talking about a shaft, so how we will check that it is in a proper form, it is into a proper shape. Okay, so we use the cylindricity, and this cylindricity rather than circularity or the roundness in the previous discussion we have made at a one cross section, but in the cylindricity this is not on the one cross section, this is all over the length. Okay, so cylindricity follows the roundness and the circularity and the straightness. Okay, so this is also called the composite. Sometimes people also call the composite tolerance because it is the in this tolerance we use the straightness and the circularity, both the tolerance in one tolerance, which is cylindricity. Okay, so as usual we have a in this example you can see, if we go with the okay, limit of size. So if we provide the size to this, so 30 plus minus 0.1. Okay, so here we have the size. Okay, so as usual, whenever we have the limit of size, okay, whenever we have the limit of size dimension, in this case 30 plus minus 0.1 if we are using, so whenever we use 30 plus minus 0.1, whenever there is a limit of size, the rule 1 applies. Okay, so rule 1 applies whenever there is a limit of size. Rule 1 applies. So we have two coaxial cylinders. Okay, so we have two coaxial cylinders. In this case, you can see like this. So this is the first cylinder and this is the second cylinder. Okay, so we have two coaxial cylinder over a length. Okay, so over full length, we have two coaxial cylinder. Okay, for the tolerance zone. Okay, so plus minus 0.1 means 0.2 mm of tolerance zone. 0.2 mm of tolerance zone we have over this cylinder. Okay, now for whole length. Okay, so if there is a length 60 mm length is this, so whole 60 mm there are two cylinders which can define the tolerance zone. Okay, so here we have tolerance zone of 0.2 mm. So the actual surface lies within these two coaxial cylinders. So the actual surface, whatever the surface will be manufactured, will lie within this tolerance zone. Okay. If I want to control the cylindricity better, then what I get, then I have to get out from the rule 1. Okay. So what should we have to do in this case? Then I have to apply cylindricity tolerance to this. Okay. So when we apply cylindricity tolerance in the feature control frame, so like this 0.1 mm. Okay, so if we apply the cylindricity to a surface, so the geometric tolerance value will be as always less than the dimensional tolerance value. Okay, so whatever be the tolerance value to the dimension, the geometric tolerance value will always be smaller than this value. Okay, so 0.2, the geometric tolerance value 0.1 will always be smaller than the dimensional tolerance value. Okay, so this is the most important part. Now we have two coaxial cylinders. Okay, which we have which is 0.1 mm apart. Okay, so we although we have 0.2 mm of tolerance zone, but whatever tolerance we have provided into the geometric tolerance value 0.1 mm, it is within this tolerance zone. Okay, whether 30.1 is the upper limit and 29.9 will be the lower limit. Okay, so within this 0.1 mm tolerance zone. So whatever the peaks and value will be there. Okay, so this is not more than the 0.1 mm. Okay, although we have 0.2 mm of tolerance zone, but the peaks and the valley in all over the cylinder will not be more than 0.1 mm because we have mentioned into the geometric tolerance value. So the actual size should be lie within the two coaxial cylinder, and this is a three-dimensional entity. Okay, so cylindricity is a three-dimensional and three-dimensional tolerance. Okay, and tolerance zone are the in this two coaxial cylinders. Okay, so most of the people call this as composite tolerance also, as I have already told you, because the cylindricity controls the circularity as well as the straightness. Okay, so circularity plus straightness is in this case, if we use circularity plus straightness. Okay, so straightness is called cylindricity. Okay, so that's why it is called the composite tolerance. Cylindricity is a surface control. Okay, so cylindricity is a surface control which we have already discussed. So that's why we cannot apply the feature that we cannot apply the maximum material condition and the minimum material condition, because the material condition modifier can only be applied to a feature of size. So in this condition, cylindricity can be only be applied to a feature. Okay, so we will be not able to apply the MMC and the LMC modifier. Okay, so form control is and the one of the most important part, if I will tell you. Okay, so the cylindricity controls, these are the important points. Cylindricity controls is a GD&T tolerance from the form control group. Okay, so in the form control group, we have four geometric tolerances: straightness, flatness, circularity, and cylindricity. Okay, and guarantees the part cylindric shape by determining the two key aspects of roundness and axis straightness. Okay, the cylindricity tolerance zone is represented by the two concentric cylinders. Okay, or we can say two coaxial cylinders. So we can also say two coaxial cylinders. These cylinders run along the entire length of the curved surface. Okay, so one on the inside and other on the outside, creating a perfect cylinder boundary around the part entire surface. Okay, so the cylindricity controls tolerance zone is a volume enclosed by a radial separation between these two concentric cylinders. The difference in their shape is the applied cylindrical tolerance limit. Okay, so whatever limit we have applied, let's say these are two coaxial cylinders over the length like this. Okay, so this is the distance between, this is the tolerance zone. In this case, 0.2 mm is the tolerance zone. So between this tolerance zone, we are providing the surface. So the actual surface lies within this tolerance zone. Okay, so this is very important part. So thus the zone is such that the entire surface of the part is constrained. Okay, so the common axis of the concentric cylinders in the tolerance zone coincides with the axis of the cylindrical part. All points of the surface under control must lie within the zone between these two concentric cylinders for approval. Okay, so whenever this surface will be into the between the two coaxial cylinders, whatever tolerance zone we have provided. In this case, if we have provided 0.1 mm of tolerance zone, so this cylinder will control the whole into the tolerance zone. Okay. Now, how can we check the cylindricity? First of all, I will let you know one of the very important thing in this discussion. Okay. So form control or the form controls are independent of the orientation location and size. Okay, so form controls this, either it's a straightness, either it's a flatness or a circularity or a cylindricity. So they are independent. They are independent of the orientation. So they are not checking the whether it is on some angle, whether it is 90 degree or at some angle. Okay, the part is tilted from the location. So the location is not, they are independent of the location also. So they are not being controlled by the location also. And the third thing, they are not controlling the size. Okay, just they are controlling the shape of the part. Okay, so these four form tolerances controls the shape of the part. So form control are never enough to fully define the sketch. Okay, so they are used to refine other controls. If we go through about the gauging as and measurement, so how we check the cylindricity of the part using a roundness measuring instrument. Okay, so roundness measuring instrument like this, you can see into this image. So it is somewhat like a CMM machine only. Okay, so with this, what we do is, it is the instrument are used to measure the cylindricity and circularity. Okay, so this instrument used to measure the cylindricity and circularity. To verify the accuracy of the cylindrical feature, we check for radial as well as the longitudinal distortion in the cylinder. Okay, so this probe over here checks multiple points over the round profile of the part. Okay, and checks that the part is within the tolerance zone or not. Okay, using a coordinate measuring machine, in this case, you can see this is a coordinate measuring machine. This is a CMM machine, and it is checking many a times accurate cylindricity measurement will not be possible without a CMM. Okay, so accuracy can only be achieved with the help of CMM machine. Okay, a CMM is far more capable of GD&T measurements compared to manual alternatives. Okay, so obviously I have already in the previous discussion also I have told you about the CMM, the possibilities of CMM. So with the help of inspection, in inspection, CMM plays a huge role, okay, to check the part whether the part is manufactured correct or not. Okay, so this is a huge advantage. An advantage of CMM is that besides cylindricity, it can measure a variety of other geometric tolerances also. Okay, so variety of tolerances like cylindricity, circularity, flatness, straightness. You can check multiple type of tolerances or the position. Okay, and other profile also. So we can check other with the help of CMM, we can inspect the other types of parts also. Okay, so this is all about cylindricity in the geometric dimensioning and tolerancing. So we have already covered the all the four form tolerances in the geometric dimensioning and tolerancing. So this is all about today. Thank you. Thanks a lot.